Hey everybody, this is Alex Merced from alexmercedcoder.com, and this is a video about inheritance versus composition regarding constructing your objects. Now I'm going to construct your objects in a more manual way where I'm dealing more with the object, less with creating sort of a constructor function through functions or through classes. So that way if you're not familiar with classes and constructors and all that stuff, this should still illustrate the same idea. Okay, so first let's just create a base class. So let's do const ninja. Okay, const ninja. And const ninja, basically the only thing about ninjas that we know so far is that ninjas have ninja stars. And they always start off with 10 ninja stars. Okay, so that's all we know about ninjas so far. But we'll say that some ninjas have more than 10 ninja stars, or I mean they actually have other powers. Okay, so what we'll do is we'll create a couple special new ninjas. Okay, so what we'll do is we will say there's a lightning ninja, or actually we'll just say there's a fire ninja. And I'm going to just use, I'm going to directly work with prototypes. I'm not going to use functions to work with prototypes or classes to work with prototypes, just so you can kind of keep this simple. So what I'm going to do is I'm going to use this function here called object.setPrototypeOf. Not necessarily the best way to do it. Again, this is just more for teaching purposes. And basically how object-oriented programming works in JavaScript is that everything is an object. And everything connects to other objects. So that way, it's not like other programming languages where objects don't exist until you define how they look like. So when you create classes in other languages, what you're doing is you're defining the shape of the information. What kind of functions will it have? What kind of data will it have? And then you can create it. In JavaScript, objects are something you can already create out of the box. Okay, so if you're watching this, you should at least be familiar with objects in JavaScript already. And basically the way object-oriented programming works, instead of creating a definition of what an object looks like, you create objects that other objects refer to. And then basically that's where all these predefined properties and methods and functions exist. That object that it's referring to, it's called its prototype. Okay? So basically, again, you're not creating a predefined setup. You are actually literally creating something for it to refer to, so that way you're not duplicating those same properties over again. So it'll always just refer to that prototype as far as how those properties work, instead of just recreating those properties and recreating that whole data structure. Okay, and there's pros and cons to that, but it's sort of a unique quirk to how JavaScript works. So in this case, what this function is doing is just more explicitly setting that prototype. Which is what's happening when you use classes or you use constructor functions. So essentially what I'm saying here is I'm going to create a new object. So this empty brackets represents a new object that's just being created. And then the second argument is what object is its prototype. So I'm going to say ninja is its prototype. So fire ninjas from the get-go now, borrow from ninja. So if I go if I do console.log fire ninja dot ninja stars. Okay, I should get the number 10 because it'll say, oh, fire ninjas don't have ninja stars, but ninja is its prototype. So let me go take a look at ninja. Ninja does have ninja stars, so we'll just use that as the starting point. So save. Okay. Save. Let's run it. Where's my terminal? Let's try a new one. New terminal. There we go. Let me get rid of the old terminal. Oh, now they're all working. Nope. Get rid of that one. Cool. Let's see here. And if I do node testing.js, see, I get 10 because it's referring to its prototypes property. And again, that object could have a prototype, and that object could have a prototype, but you can only have one. And that's what inheritance is. It's essentially that whole chain of, okay, I have a parent, I have a parent, I have a parent, and I'm going to keep referring up this chain to find all the properties. Okay, so now I could do this, and I could do this a few more times. So then I could add any special properties for Fire Ninjas to the Fire Ninja object, and then create new objects that use that as a prototype, which would then borrow from Fire Ninja and Ninja. And I could do the same thing with, Wind Ninja. And I can do something with like a Thunder Ninja. Problem with this is, what if I want to create a Wind and Thunder Ninja, or a Fire Wind and Thunder Ninja? What would happen is that I can't, because at the next level, the next object I create could either I could set the prototype as Thunder Ninja, as Wind Ninja, as Fire Ninja, but I can't set it to both. So what happens is that the only way for me to have a Fire, Wind, and Thunder Ninja is to borrow from one of these, and then still manually have to go add in the properties of Wind and Fire. So that's not necessarily cool. That might be fine, but that's inheritance. So the idea is you only can inherit from one. So where that kind of breaks down is when you have two things that inherit from a base class, but then you have another class that needs to borrow from both of those subclasses. Okay? But that's how the prototype chain works. And that's how classes work in most languages. You can only inherit from one other object. Composition, and that's usually built into the language. In composition is not necessarily built into the language. It's something you can do. It's just sort of a technique you can do. Okay, so let me get rid of these. We'll keep the base ninja class, or base ninja object. So we have this ninja object, and let's say I want to create, so we'll say we have lightning powers, or thunder powers, thunder, and we'll make that a new object. So let's do this as const thunder equals thunder. Okay, and then thunder is just a function that goes console.log thunderbolt. Okay, now I'll make a few more of these. Control C. So compositions would be more like Build-A-Bear, where instead of saying, hey, I'm inheriting, so this inherits from this and this inherits from this, I'm gonna say, hey, I'm gonna make a bunch of pieces and then assemble them in different ways. So this way, I don't have to worry about what I'm inheriting from, because I'm just borrowing a little bit from everything. Sizzle like a fire. Sizzle. Okay, and then we'll have a wind. Or we did wind. We'll just go woo, woo, the wind blowing, and that power will be called wind. So in this case, how would I assemble all this together? I could create a function that does that for me, and that's what I want to do. So I'll just create a function. This is referred to as a factory function that kind of builds my objects for me. So I have all these pieces, and the factory will just kind of assemble it for me. So we'll call this this function called const ninja factory. Const ninja factory, and I need that's an arrow function, so I gotta be like this, and I want you to pass in a name, and then you can pass in several other arguments, and all those arguments I'm going to assume that they're powers you want to add to the ninja. So I'm going to use the rest operator to grab all the other arguments and put them into an array called powers. So that's what that does. Okay, and then what we're going to do is we're going to say make a new ninja. So we're going to create a variable called new ninja. Okay, and we're going to say it equals a ninja. We'll spread the ninja. Okay, using the spread operator, it'll just take all the properties of ninja and add it. So ninja stars gets added. But then we also want to add the name. So you gave me the name and it's called name, so we'll just leave it like that. But then I need to add powers. And actually I'm going to keep this as let new ninja so that we can reassign it. Because you'll see what I'm going to do in a second. So we're going to do this as a loop. So for every power of powers, so for every power you pass in, we'll loop. Then we'll use a switch statement. The switch statement will take a look at the power, but we'll make sure it's lowercase, so to lowercase. Okay, so switch power to lowercase. And then we'll have a possibility for thunder, fire, wind. So first one's thunder. That's a case, so it's case thunder. Meaning if thunder is what power that to lowercase is, then new ninja equals wherever the new ninja is so far, so that we grab everything we've added to new ninja so far, plus thunder. I'm sure that's what, yep, thunder. Okay, so then I'll add everything in the thunder object, so it'll add the thunder power. Okay, and then I just basically do this again and again for the other two. So I'll just kind of, well, I have to add break. So let me add break to it. There we go. Okay. So let me just fix the spacing on all that. This one is fire. So then we'll combine the ninja so far with fire. And by always spreading the new ninja, you're always making sure that any powers you've already added are still in there. Fire, wind. So let's do it one more time for wind. Cool. Okay, and so that'll construct the ninja that I want. So let's do some examples. So console.log. We call this ninja factory is the function. Ninja factory. And we'll say we'll give it the name Ryu. And we're going to say it has wind powers. So just wind powers, and watch what happens. So console log the resulting ninja. And if, oh, I never returned the ninja. So let's go back to the function. That's still the loop, so I want to get out of the loop. And then we want to return new ninja. Save. Okay, let's try that again. And there you go. So you end up with a ninja with these properties. Now, if I were to change this to window, Ryu, wind, fire. See, now it has wind and fire powers. Now, what if I only wanted to have fire and thunder powers? No fire, so just fire and thunder. And now it has wind and thunder. Okay, so that's the beauty of composition. Composition, you don't have to worry about like what inherits from what. You just create your pieces and you assemble them together. That's composition. So you don't have to create a bunch of classes and prototypes. You just, you know, build out your pieces as needed and assemble it how you want. Now, there aren't, as far as I'm aware, there aren't any substantial performance differences between the two that matter. And I think if there was, I think it would favor composition from, unless you get into like really, like you're talking about like creating like millions of a object, or million instances. So in that case, maybe if you're creating like a really large scale video game, which you're probably not doing in JavaScript. But yeah, those are two techniques for creating your objects. I could either just have create a base object that inherits from that object, then inherits from that object, or I can create a bunch of pieces and assemble them together, and that's composition, so inheritance or composition. So hopefully you guys found that interesting. Hopefully this helps illustrate a little bit more about how prototypes work, about what composition is, about what inheritance is, and you guys have a great day and enjoy.